So I'm going to end this section on the periodic table over the concept of a mole, because we've talked about if we look at an individual box here, let's say we picked copper, and we said it has 29 protons, it has a symbol associated with it, and I told you that this number, the 63.55 in this case for copper, is the atomic mass or weighted average mass for all the copper isotopes, and that's typically in AMUs, okay? Well, an atomic mass unit is so small that it doesn't make a lot of sense to use it, and so we use the concept of a mole, and we say 1 mole of anything, so it could be of copper, of nickel, of moles, is equal to 6.02 times 10 to the 23rd things. Okay, it's very similar to the concept of a dozen, which is 12 things. If you have a hard time understanding what this huge number means, it's like 602, sextillion. It's a huge number. Kind of think of it as a dozen. It's a counted number just for very, very small things that we use. Some people call this Avogadro's number, and that's because it was determined by by Avogadro. And interestingly, it was, if you look back in some of the history books, even Benjamin Franklin was on the path of deriving that number from kind of other empirical data. And so anyways, when we talk about copper or we talk about anything, that number is on the periodic table, and you can take it. And since I was talking about neon, I'm going to use neon again. So I'm going to use, and with significant figures, this is going to probably not work out perfectly, but let's say that number underneath neon, I told you, is the number of AMUs in one neon atom. And I kind of wink when I say that because no neon atom weighs that much. We've already gone through that. So on average, it's a weighted average mass. So if we did this conversion and we said, okay, I'm going to say 1 AMU is equal to 1.66 times 10 to the negative 24th grams, we know that we can convert that to grams, but it would be an extremely small number. So what we would typically do is say, well, there are 6.02 times 10 to the 23rd neon atoms in 1 mole of neon atoms. And so really this is meant to be, and I'm going to have to truncate my significant figures. You know that this is going to end up being 20.2 with significant figures in the end. When I solve this, if I multiply 20.179 times 1.66 times 10 to the negative 24th times Avogadro's number, I get 20.2 grams of neon for every 1 mole of neon. Okay, so it's not a mistake that these two numbers, depending on what we put on them, what the unit, it's the same exact number. So when you have a block on the periodic table like this, you can do two things. You can say it's an atomic mass, which means the units would be 20.179 AMUs for every 1 neon atom. Or you can say what we call the molar mass, the mass of a 1 mole of these, so 20.179 grams in I'll put 1 mole of neon. And you can see that that is so much more useful because 20 grams I can measure out, and then I'd have a mole of neon. Okay, so that number on the periodic table, that bottom number, and this is another good test question, if I said I had, let's say I had 58.97 grams of cobalt and 63.55 grams of copper, which one would have more atoms? And the answer is neither. It's like saying I have a dozen cars or a dozen dogs. What do I have more of? You have the same amount because they weigh different amounts because the nucleus is different and the number of electrons and everything is different. So that number is the molar mass, how many grams there are in a mole, right? So make sure you understand that, and you can use it for conversion factors. So, for instance, if I asked you how many moles are in 250 grams of, let's say, zinc. Well, you solve these problems just like we have. Moles of zinc is what's being asked for. And the only other number is 250 grams of zinc. So I need a conversion factor, and this is where you have to know something. You have to know the number on the periodic table, 60.41. What was it? 65.41. That's how many grams of zinc are in 1 mole of zinc. And you might say, well, how do I know to put the grams on bottom? Well, that's why we did our first section. That's how we cancel out what we're doing. So I take 250, divide it by 65.41, and I get 3.82 moles of zinc. Okay, and you could do the opposite. If you had moles, then you just multiply by the molar mass to solve this. So those are some problems that you could do. If you had a compound, let's say something like CH4, well, you would have to take the number, that 12.01 for carbon, and then hydrogen, which is, I'm going to just put as 1.01, you'd have to add these up. So you'd have to say plus 4 times 1.01, because these are the molar masses. There's only one of these, so I don't have to multiply it by anything. And I would get 16.05, and then I'd put the units on it, grams per 1 mole for that CH4. So you can add these atoms up to come up with the formulas, and we haven't talked about formulas, but we will in our next section, and you've taken some chemistry. You know that's 1 carbon and 4 hydrogens. And so you can add these things up based on the weighted average mass or the molar mass to get a conversion factor. Now, don't be deceived. Sometimes people will write things like let's get one off the periodic table. Let's say we had something like potassium, okay? So potassium is 30.10, and sometimes people write grams per mole in an order like that. They write it all on the same line. Remember, that means 39.10 grams in every 1 mole. Make sure you write things as conversion factors so that you can use them as conversion factors. So if you're wrestling around how to solve a problem, make sure you rewrite it, and it might give you a hint on how to solve the problem. Okay, so like I said, you can go from grams to moles, or you can go moles to grams. So if I said you have 7.24 moles of argon gas, how many grams are present? Well, 7.24 moles of argon, and I know that I want grams of argon. Then I get that off my periodic table. Argon is 39.95, 39.95 grams in every 1 mole. And I know that I put that on the top because I want grams on top. And then I just take 7.24 times 39.95, and I get, with 3 significant figures, 289 grams of argon. Okay? So make sure you can do those conversions. We're going to use them throughout the semester.